Welcome to SysEng Quick. My name is John, and today I'll show you some caching strategies for building Docker containers with GitHub Action workflows. In the first video, we used a simple Docker file that takes less than a minute to build. But what if your Docker file is more complicated? If you were building locally, Docker would cache the layers that didn't change and rebuild the image faster. How can we do that when using GitHub Actions? You could build an intermediate container. Move everything that might be cached into another Docker file, publish that container, and then rebuild your container from your new intermediate. That could work, but it gets complicated if you do have to change the intermediate container. Instead of updating one Docker file, now you have to update two. Let's look at some ways you could use Docker layer caching in GitHub Actions. I've made some small changes to the build container action from the first video. The important changes are in the last step in the build container workflow. We've added cache from and cache to. In cache from, we set the cache type to GHA, GitHub Actions Cache, and the scope is container. The scope names our cache, which can be useful when building multiple container images, though it isn't really doing much in our example here. In cache to, it's the same, but we've added mode equals max. Again, in this particular example, it doesn't really do anything, but it would be useful if we were building multi-stage Docker containers. Let's go to GitHub and try it out. Since we didn't change the Docker file, the new workflow didn't get triggered automatically. First, we'll go into Actions and take a look at the Actions cache. Well, right now, we have no caches. So let's go back to our workflow, and if we go into our workflows, you can see that both of them had to rebuild the entire image. If we scroll down here, we'll see that it had to install Poetry, even though we made no changes when pushing the 1.0 tag. This is exactly the same as we had in the main branch. Let's trigger a manual run and see what happens. We'll go to Build Container, Run Workflow, Branch Main, and select Run. It's running the workflow now. Should be done in about a minute. There we go. It took about 34 seconds. When we go back to our cache now, you can see we do have a cache. If we rerun our workflow, will it be faster? Well, maybe. The overhead of running the job might overwhelm any time savings we get from the cache for this trivial example. But let's try it anyway and see what happens. I also want to know if it used the cache. So there we go, the job is queued up. Okay, this run took 30 seconds. Not exactly phenomenal, but it was faster. Let's see if it used the cache. We'll go down to the build push container image action. Take a look at Poetry. Yes, this step was cached now. It used the cache rather than reinstalling Poetry from the upstream. Okay, why don't we see if we can add something else to the Docker file? Let's go back to VS Code. And why don't we add a new Python library, Pydantic? We'll add a new step, run python 3 mpip install Pydantic. I'll go ahead and save that. Let's go ahead and commit this, add Pydantic. And we'll push that up to main. And let's see if it's running our workflow now. Go back to all workflows. There we go. It has been triggered. There we go. It took 25 seconds, even though we had to add Pydantic. If we go into the workflow, did it actually use the cache? Let's just make sure, and yes, Poetry was cached. Did have to install Pydantic because that wasn't there before. So you might want to tag your Docker images with your repo tags. We did that manually in the first video by running the workflow on the tag. But it had to create the container from scratch because there was no cache. Will it use the cache now? Yes, and also no. GitHub stores the actions cache by branch. Since we push to main, we're using the main branch cache. Workflows can only access their own branch's cache and the default branch cache. You can trigger a workflow from a tag push, but that workflow will not have an associated branch. A tag could be in any number of branches. So in this workflow, we'll be using a cache in this specific tag. Tags aren't meant to change, so this cache is useless. Nothing else can reference it, and we're probably never replacing the tag. But remember that I said it could also access the cache of the default branch, and main is our default branch. So does that solve our problem? Well, not entirely. Launching a workflow from a tag will use the main branch cache. But if you're making a tag, you probably just push that commit to main, so your changes haven't had time to reach the cache. So now you're building the container twice, once for the push to main and once for the tag. If we want to add the get tag to our containers, there are a few options. One way would be to put the tag somewhere in the repo, push that up to main, and use that file to tag the container. Let's see how that might work. I've added a file, Docker tag, which has the value 2.0.0 in it. In our workflow, I've added another step called get Docker tag, which places the Docker tag value into an environment variable. We add this value as one of the tags in our metadata step. Let's merge these changes and try it out. I've gone ahead and pushed them up. Let's go back to GitHub Actions to the Actions page, to our build container workflow, and let's run this workflow manually. Run workflow. We'll select the main branch. There's no tag, remember, and we'll hit run workflow. And let's see what happens now. Okay, everything finished in about 21 seconds. So it definitely hit the cache. I'm sure it couldn't have installed Poetry and Pydantic that quickly. So do we have a 2.0.0 tag in our container? Let's go find out. We'll go over to code, go to our container build workflow, and yes, there we go. Our 2.0.0 tag is there, even though we didn't push to a tag, and we don't have any tag 2.0.0. So that's one method, but I don't really like it. You have to make sure this file and the get tag are in sync, and this file has to be updated first. If you don't update this file, you just overwrote one of your old tags. Oops. Guess we're rerunning the workflow from that tag to get that back. But what if we could wait for the cache to be built and then push the image with the tag? There is a community GitHub action that uses the GitHub API to check on the outcome of a job run in the workflow. Let's see how we might use that. I'm going to merge in the branch GHA tag. There we go. So I have made some minor changes to the build container workflow. First, I've removed all tags other than the branch event. And I've changed push to false. This way, we build the container and cache the layers, but we don't push the container to the registry. We'll do that in a separate workflow. That's called tag container. This workflow is pretty similar to the build workflow, but there are a few minor differences. First, in the on-push event trigger, we don't have branches or paths here. This workflow is only triggered by pushing a tag or via a manual run. In the build push container job, we have a new step which uses the community wait on check action to wait for the container cache to be created. The reference is set to the main branch where our workflow was triggered. The check name matches the name of the job in the build container workflow, which you can see I've put right here. And you do need to name the workflow. This dictionary key is not the same as the name, even if you don't have this key. The repo token is used to access the API, and the wait interval is how long in seconds to wait between completion checks. The workflow will be paused here until the other job reports success or failure. I couldn't tell from the documentation if there was an action timeout. Leave me a comment if I overlooked it. The rest of the steps are standard. We've added the tags back, but only the tag ref and the SHA tag. When using a tag, it will automatically add latest, and will never have a branch in this workflow. You could add a raw tag with the value main if you wanted to keep the branch tag, but I'm not really sure I see the value in that. Finally, in build push action, we set push back to true, and we remove cache 2. Remember, caches are set per branch, and we don't have one, so I don't see any reason to ever store a tag cache. Let's merge this into main and push it up to GitHub. Go ahead and do a git push. We need this to be in the default branch because we have a new workflow, and we can't change the default branch or we won't have access to the main cache. Remember, it's not that you have access to the main cache, it's the default branch cache. If we change the default branch, we no longer have any cache we can access. Let's trigger this workflow by adding something new to our Docker file. In Dockerfile, we'll add another library, maybe DNS Python. We'll do another run python 3-mpip DNS Python. Now we'll go ahead and add that. Add DNS Python. We'll go ahead and push that up to main. And now I'll go ahead and make a tag, get tag 2.1.0, and I will do git push origin 210 to do that. Let's go see how our workflows are doing in GitHub. Over on the actions page, you can see we have 2 actions running. Let's go look at the tag first and make sure it's waiting on the build cache. Over here in build push container, well, we did see the other one went green pretty quickly, so I think it did wait. And you can see over here, we do have things cached. Here's DNS Python, Pydantic, and Poetry. That means that we did have the cache because DNS Python got picked up in the cache from our main push. And we're using the entire cache to set the tag here. Let's go check if we have our image now. Go back to code, go down to our packages, and there we go. We have the main one, and we have 210 latest and our SHA tag. Everything looks good. Okay, so this works, but I don't really like it either. It's kind of complicated to set up, and it might be fragile. What if the community stops maintaining the GitHub action? I haven't really used this enough to say that it's stable setup either. This is really only a proof of concept based on things I read on GitHub issue threads. So, is there another option? Well, yeah, there is. Remember when we first added the cache options to Docker build push action, we selected GHA as the type. Maybe you wondered if there are other types, and the answer is yes, there are. We can add a cache inside the container registry itself. Let's see how that works. I'm going to go ahead and do a git checkout to reg tag, and we're going to do a git rebase on main. I'm going to push that back up, and then we'll merge that into main. Okay, there we go. So now everything should look good. So what have we changed? Well, first, as you can see, I deleted the tag container. We're down to one workflow again. So what does it look like? Well, first, we only have the tag trigger here. And in the Docker build push action, we've changed our cache from and cache to use the registry type. we also need to supply a reference for the name where the cache will be stored. You can use whatever you like for the cache name so long as it's the same in both cache from and cache to. We keep mode max here to get the same behavior we would have had from mode max in GitHub Actions cache. Let's go ahead and push this up to main. We can update our workflows. And now I'll go back to the GitHub Actions. You can see we only have one action now. So let's trigger our first run manually to seed the cache. Remember, we don't have the GitHub cache anymore. Let's run the workflow, run it from the main branch. The branch actually isn't important here. As soon as it completes though, which will probably take a minute, we'll be able to use the cache. It actually completed a bit sooner than I thought. Let's go see how it went. Remember, we shouldn't be seeing anything cached now because everything has no cache. This is our first cache run. If we go to our build push, we can see that we installed Python. Yep, there we go. But we had to install Poetry manually. We did not have this one cached. Okay, there we go. Let's go ahead and try adding another Python library to our Docker file. So we'll add one more, run python 3-m pip install, and I don't know, fqdn. Let's install that. Why not? Let's go ahead and add fqdn. We'll go ahead and push this up, but that will not trigger a run anymore. Remember, we're not triggering actions on push anymore. We're only triggering them on the tag. Let's make a new tag, get tag 220, and we will do a get push origin 220. There we go. There's our new tag. If we go back to our actions, did this start running? Yes, it did. Add fqdn. Let's see if the new cache worked. There we go. Took 24 seconds. That was faster. Again, we're not doing anything complicated, so won't see a lot of improvement, but there should be some. Let's confirm this was actually cached. If we scroll down a little bit, we can see, yes, pip install Python, extracting this is a cache. Nothing else was done. Cached, 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 yes. Everything was already in the cache. And it will be if we do something in the next tag as well. So everything looks good now. And this is my preferred caching strategy. Now, one minor issue is that you cannot use paths with tag push events. This means every time you push a tag, your container will get rebuilt. Now, depending on your workflow, that may not be a bad thing. You might need to rebuild the container because other files in your repo changed, not just the Docker file, and it might not always be practical to list them. Well, I hope this has been helpful. If you have a different caching strategy, leave me a comment. And while you're there, hit those like and subscribe buttons. It helps the channel. Thanks for watching. I'll see you next time.